Welcome back. In this video, let us see what is a forward bias and reverse bias in power electronics. So normally in the power electronic devices like diode, SCR, MOSFET, IGBT, BJT, these are all forward bias and reverse bias under some particular operating condition. So let us see the correct exact definition for forward bias and reverse bias. Consider this is the diode, this is the anode and this is the cathode. So here most of them have used the definition of a forward bias is the anode of the particular semiconductor device or a diode is connected to a positive terminal of the battery and the negative terminal will be connected to the cathode of the particular semiconductor device. This is most commonly used definition for forward bias condition of a particular semiconductor device. Right, there is anode is connected to positive terminal of the battery and cathode will be connected to the negative terminal of the battery. But this is not a correct explanation. So let us see what is the correct explanation for forward bias and the reverse bias condition of a particular semiconductor device. Let us see. So here consider this the diode. If it is forward bias means the anode voltage must be greater than the cathode voltage, means the particular device is under forward bias condition, that is it is ready to conduct. So consider this the semiconductor device diode and here the anode terminal voltages will be for 5 volt and the cathode terminal voltage will be for 2 volt. So compare these two voltages. The anode voltage is greater than the cathode voltage so that the device will be forward biased. So what is mean by reverse bias? The anode voltage is less than the cathode voltage, means that is called as reverse bias condition. So consider this is the diode, the anode voltage will be 3 volt and the cathode voltage will be 6 volt. So compare these two voltages. So normally that 3 voltage is less than 6 volt, so that the diode is under reverse bias condition. So this is the correct explanation for forward bias and the reverse bias condition of a particular semiconductor device. So if the anode voltage is greater than cathode voltage, the device is under forward bias condition, and that anode voltage is less than the cathode voltage, the particular semiconductor device or a power electronic device is under reverse bias condition. Let us see that forward bias and reverse bias conditions with some examples. So here I have taken this semiconductor device as a diode. This is the anode and this is the cathode. Here now I am considering the anode voltage will be minus 3 volt and the cathode voltage will be minus 7 volt. So compare these two voltages. So actually these two are negative voltages, right? Anode voltage is negative value, cathode is also a negative value. Now we are comparing these two negative voltages of anode and cathode. So compare these two values. The minus 3 volt is greater than minus 7 volt, right? This is the negative polarity. So that minus 3 voltage is normally greater than the minus 7 volt. So that anode voltage is greater than cathode voltage. So particular diode is under forward bias condition. I think it's clear. And consider this SCR or the semiconductor device. Anode voltage will be minus 7 volt and cathode voltage will be minus 5 volt. Now compare these two voltages. The minus 7 volt will be less than minus 5 volt. So the anode voltage is less than that cathode voltage, so that particular semiconductor device is reverse bias condition. And now take another one example. So again I am considering the SCR. Now the anode voltage of the SCR is 8 volt and the cathode voltage is 10 volt. So now compare these two voltages. 8 volt is less than the 10 volt, that is the anode voltage is less than the cathode voltage, so that particular semiconductor device is under reverse bias condition. Now consider this one. Again I am taking the diode as the semiconductor device. Anode voltage is 5 volt and cathode voltage will be 1 volt and the anode voltage is greater than the cathode voltage, so that it is under forward bias conditions. We can take any semiconductor devices. Just we are comparing the anode voltage and the cathode voltage according to the magnitude of the anode voltage with respect to cathode voltage. We can easily identify the particular device is under forward bias condition or reverse bias condition. And the forward bias condition is different from on state. Suppose if you are taking the diode, it is under forward bias condition means that will be automatically on. That is, the diode is the uncontrolled device. But if you are taking the SCR, even though we are forward biasing the SCR without gate signal, it is under off condition. That is, the forward bias condition not always mean that it is the device is under on state. It means the device is ready to operate. And if the SCR is turned on only after triggering the gate, that is, first we want to forward bias the thyristor, then we are going to give the gate signal means automatically on. So the forward bias condition means just the device is ready to operate. So whenever the control signal will be applied, at the time only the device is under on condition. And now the reverse condition is again not always mean that the device is under off condition. So the reverse bias condition is different from the off state of the device. So the reverse bias means it means the anode voltage is less than the cathode voltage. Yeah, I hope that everyone can get clear idea about what is a forward bias and reverse bias condition in a particular semiconductor device. Thank you. Friends, subscribe our channel AAA Encyclopedia for learning all basic concepts comes under electrical and electronics engineering and enhance your knowledge.